I was going to do this again. What are definite integrals? What do they look like? Right. Definite integrals have a bound. And according to the fundamental theorem of calculus, part 2, it gives us a finite answer. An indefinite integral doesn't have a domain. The big difference is this. Oh, did you get the top part here? Did you get that part? Since it doesn't have an A to B, a domain that we're integrating over, our numbers are going to be infinite. There are infinite number of possibilities our answers can be. So you notice in definite integrals, these are going to be solid numbers because we plug in a value inside the function in the integral, and we get a number. This we're going to always end up having a plus C after it. Can anybody guess why? Why will we have a plus C on an indefinite integral? Yeah. Why? Why is there going to be a constant back there? How do we know there's going to be a constant? Right. Because if we take the derivative of this side, we have to end up with this. The derivative of a constant disappears. Right. So there's the reason there's an infinite number of possibilities because they're all parallel to each other. Because this gives us a slope, the slope of the curve or the line, depending on where plus C is, plus or it could be negative also. So that's what we have to be very, very conscious about. If you don't have any A or B intervals, the upper and lower bounds, then you have to make sure your answer contains a plus C at the end. If it doesn't, it's wrong. I can't tell you the number of times. It's like, how many times have we done limits and you forget to put the as x goes to infinity? Yeah. It's just forget about it. Don't forget the plus C. Okay. Substitution method. Running the chain rule backwards. Remember, we're doing substitution, so our function with respect to x is going to be defined by u raised to some power. Then we also have to have a du dx times dx. Because whenever you do with substitution and you convert the function to u, you also have to tell me the du dx part. And we're integrating it with respect to x in the overall. So once it matches this condition here, whatever your u is, whatever power du dx, and there's a derivative of it, then we know it's going to be this way. It's going to be u n plus 1 over n plus 1 plus c. There's our first rule. Example here. And there's nothing new because we've done this in the past, but we've always had it f of x to some power n dx, or it could be x to the power n, which equals x n plus 1 over n plus 1 plus c. Let's look at example 1. Find the integral of x cubed plus x to the 5th times 3x squared plus 1 dx. Let's put the formula down we're looking at. Remember, we're gonna be using this formula here. U to the power n du dx u n plus 1 over n plus 1 plus c. So the part we have to look at here is which one can the substitution method work? If so, what is u going to be defined as? U can only be one of those two. And it's easier than you think. If you look at the formula, what does u have in the formula? It has to have an exponent. Well, because we have to be able to take a derivative of it, and we have to have an exponent for the n plus 1. This one can't work because how will we get the 5? So it can never be a smaller exponent. It has to be the largest exponent.
So it doesn't matter the order of the like.
No, how it's arranged? No, not at all. Now, also, because this is u to the power n, is this du dx? So what's the derivative of u? 3x squared plus 1. There it is. So what we have here is u to the power 5 du dx. So it tells us our answer is going to be what? Our answer is u n plus 1 over n plus 1. 5 plus 1 over 5 plus 1 plus c. U is x cubed plus x to the 6th over 6 plus c. And there's your answer.
So
So, yeah, what you have to look for is, first off, since you have two parentheses here, which one has an exponent? That one is gonna tell us which one is u. Then once we define u, take the derivative of it, and it has to be the second one. Right. But essentially, once you take the derivative and this match that, no brainer. We know that's this part. This is this part. But example 2 shows us there may be situations where we're missing a part, a number. Square root of 2x plus 1 dx. Yes, that's the first thing we have to do. We have to convert this to an exponent. So now we know what u is. What is u? 2x plus 1. N is 1/2. So the derivative of u is the constant disappears, derivative of x is 1, so it's just 2. We're missing that 2. We can, as long as it's simply a number, and we're missing the 2 for the du dx, if we put 2 right there, we have to cancel it by putting a 1/2 out there. You have to put the reciprocal. Whatever you put inside there, you have to put the reciprocal out in front. Because they're both still the same thing. There. 2 is a constant. Constant I can take out in front and it cancels, nothing changes. I just change the way it looks. So now we're in the u to the power n du dx. Now we have that. No, that's the integral. We haven't taken the integral yet. So this 1/2 stays out in front. We have u, which is 2x plus 1. So it's 1/2 plus 1 over 1/2 plus 1 plus c. No, the plugins are there. The reciprocal goes out in front. And that just stays there. So our answer, this on the bottom here, one half plus 1, that's 1/2 plus 2 over 2 is 3 over 2. 2x plus 1, 3/2. What do you do with this denominator? So we have 1/2 out in front. If it says it's on the bottom, you have to reciprocate it. And it comes out in front. 2x plus 1 to the power 3/2 plus c. The 2's cancel. So we get 1/3 2x plus 1 to the 3/2 power plus c. And there's your answer. Or if you want to make it look nicer, you could put 2x plus 1 to the 3 halves over 3 plus c. Any questions so far? If you're missing an integer on the inside to make our formula fit, you have to put the reciprocal of it out in front.
So not in the back.
Only if it's a number. If it was 2x, we couldn't do anything right now. That you have to wait till next semester.
Wait, so only if it's a number with no variable.
Right. If it's an integer. Or it can be a fraction also. As long as it's a real, actually, it's a rational number. But if it's a rational number, then you put the reciprocal of it in front. If we're missing a 3 over 4, then you have to put a 4 over 3 in front. Has to be the reciprocal of it. Theorem 6. The substitution rule. Our substitute variable u, if that equals some function g of x, if it is differentiable on an interval, I, and if f of x is a continuous function on that same interval, then we know that the composite function f of g of x times g prime of x dx is equal to f of u du. That's what we just talked about. We have a composite function. Well, that's what we said earlier. U is a function inside a bigger function, which is to the power n. So it's a function within a function. Take the derivative of it, that's g prime. Whatever is inside there, it's g. That's g prime dx. So it's the same thing. So we've been using the substitution rule without giving it a name.
So with that. So is this still like chain rule?
They're backwards, yeah. That's exactly, yeah, this is a chain rule backwards, which is exactly what this is, but with f of x, g of x instead of u. Remember,
Like chain rule for derivatives should be f prime times g of x, right? That's G.
so this could be g of x to the power n. So it's u to the power n. That's what it's saying. or what we just talked about, f of g of x, g prime of x dx. The first step is substitute u for g of x. And du is the derivative of x, and g of x. And that gives us the integral of f of u du. Integrate with respect to u. And then replace u with g of x and you're done. Those are the steps. All right, let's look at an example here. I wait till everybody write this down. All right. Example 3. Secant squared 5x plus 1 times 5 dx. So here we see it's a function within a function. It's secant squared of x. So this is f and that's g. So our first step, define u. What is u going to equal? Yeah, it's the internal function. 5x plus 1. 1b. Find du. And du is 5. That works. That works. So now step 2 is integrate with respect to u. So what we have to do here is secant squared u du. The integral of secant squared is tangent plus c. Step 3, replace u with g of x. And there's our answer. Any questions so far? No, I can't stress enough. Don't just copy what I'm putting on the board. You have to understand what you're writing. Anybody can write that. I can get elementary school kids to write your notes for you. But unless you know what you're writing, it makes no sense doing this.
So. I mean, all that happened there, secant squared was the derivative of 10, right? So you went back.
Right. Right.
And then all you did was multiply.
Actually, you guys,
First time in the last example, what happens to the constant yield?
it just stays there. We'll get into a point where, because you can't time it, because if you multiply by c, then it's going to change the whole function itself. This is just a constant. When you take a derivative of it, what happens to a derivative of constant? Disappears. And so we have this equation.
Five, so integral secant squared u du.
Yeah, the derivative of internal here, remember the chain rule? We take the derivative of the outside, which is tangent, times the derivative of the inside, which is 5. So that's right here. So no, I'm sorry, working here. It's a derivative of tangent secant squared, derivative of 5x plus 1 is 5. So that's the chain rule backwards.
Defense times G.
Yes, yes. This is f of g, g prime, dx.
So then.
So this one, our u is what? 7 theta plus 3. Therefore, our du is, do we have a 7 here? Do we have a 7? Nope, we don't have a du. This is d theta. So we have to put a 7 there. Our du. Since we have to put a 7 there, we have to put a 1/7 out here. So we have 1/7. The integral of cosine is what? So it's sine of 7 theta plus 3 plus c. And how do you test your answer? How do you test to see if that's right? Check your answer. So we have y is equal to 1/7 sine, let's say 7x plus 3 plus some constant. Find y prime. Yeah, the constant stays there. The 1/7 stays there. The derivative of sine is cosine times the derivative of the inside. Derivative of constant disappears. That disappears, goes to 0. The 7s cancel. So my y prime is cosine 7x plus 3. This matches this. So that's how you test it. Whatever your answer is, take a derivative of it. If you end up with the question, then you're done. Example 5. Example 5 says this. Sometimes we observe that a power of x appears in the integrand, and that is one less than the power of x appearing in the argument of a function we want to integrate. This observation immediately suggests we try a substitution for a higher power of x. For example, in the integral below, we see that x cubed appears as the exponent of one factor, and this factor is multiplied by x squared. This suggests trying the substitution of u equals x cubed. So what it's saying is this. If we have this. You asked earlier, does it matter how you arrange it? Not really. Because of commutativity, we can move it around. If this bothers you, then we can move it around. Because this one's square, this one's cubed. So what is our u? X to the power 3. Because when we take a derivative of it, we get 3x squared. Well, do we have an x squared? There's an x squared. What's missing? The 3. I can put a 3 in front of there. That means I got to put a 1/3 out here. So that means my answer is, this is, well, let's rewrite this. So we have e x to the third 3x squared dx. And that is in the form of 1/3 EU du dx. What's the integral of e to the x cubed? Or what's the integral of e to the x? E to the x, because the derivative of plus c. The derivative of e to the x is e to the x. So since this sets us up already, then our answer is x cubed. As long as we have EU du, since the derivative of EU is EU du, then it's going to be EU. The integral is going to be EU. If we have that, the integral is EU plus C. Yes, e's are easy taking derivatives. They're one of the easiest things to take derivatives of when you think backwards. Because of the simplicity, it makes it more complex. So pretty much Your answer is gonna be that. Once you set it up. It's whatever you're missing, EU plus C. Example 6. Evaluate integral of x square root of 2x plus 1 dx. Now comes a problem. Because what is our u going to be? Our u is going to be 2x plus 1. What's the derivative of u? We have an x. So what are we going to do? What we have to do here is we have to take this equation and solve it for x. So I subtract 1 from both sides. So u minus 1 equals 2x. And divide by 2. So this is what x equals. So my x value becomes u minus 1 over 2. Then we have a square root of u dx. Or actually, has to be du now.
Replacing that with whatever x.
Well, yeah, because we're taking derivative integral with u now. So far, so good. What do we do now? Well, we have to write this one. U minus 1 over 2, u to the power 1/2. So what are we gonna do now?
To x, x plus 1.
So you're gonna plug that back in here. We haven't done the integral yet. If we plug this back into here, this will cancel. And we'll get x again. So now we have to do the integral. Okay, so this one. That's a 2. Okay, we still need, for the integral inside here, we still need the du. this denominator come out, so we have 1/2 times 1/2. U minus 1. And that takes care of that. So we know that square root of 2x plus 1 dx is equal to 1/2 square root of u du because of this. So that one is there. This one comes out. So we have 1/4. Now inside here, we can distribute. U times u to the power 1/2 minus u to the power 1/2 du. U times u to the power 1/2. What do you do with the exponents? Whenever you multiply the same bases, you add them. So 2/2 plus 1/2 is u to the 3/2. Now we're ready to integrate. So we have 1/4 u to the 3/2 minus u to the 1/2 dx or du. Now we integrate. What does this one become? U 3/2 plus 1 over 3/2 plus 1 minus 1/2 plus 1, 1/2 plus 1 plus c. Two over two makes it 5/2, 5/2, 3/2, 3/2. And just 2/5. 2/3. Distribute that one in there. The 4 cancels with the 2s. So we got 1/10 u 5/2, 1/6 u 3/2 plus c. Remember, u was our 2x plus 1. Now we can put it back in there. So it's 2x plus 1 to the 5/2 over 10. 2x plus 1 to the 3/2 over 6 plus c. And there's my answer. What questions do you have about that? The only part that you have to will be the hard part is this one here. Square root of 2x plus 1 dx is the same thing when I substitute it. It's the square root of u times du. Du is 2, so I have to put a 1/2 in front.
But I think that's right. So
This is, yeah, this,
going all the way back to. We got integral u minus 1/2 times u to the power 1/2 du.
mhm.
And then from there, you have to plug that 2 in, and you put it in front of the u, is that what that came from?
Well, yeah, because the derivative here, that's where the 2, so that's where the 1/2 came from for this one.
So you put 2 in front of the u, and has to drop from the integral, which is the reciprocal.
Right.
And then,
Then I distribute that u to the power 1/2 to both of those.
okay, for the second one,
U to the power 1/2 times u is u to the power 1/2 times u to the first. This is -1, so u1/2 times 1 is u to the power 1/2. I just distributed this one to both of those inside there.
but what about in front of the integral?
The 1/4?
Yeah.
The 1/2 from this one,
Oh,
and then the 1/2 from that one.
Oof.
Because when I change it to 1/2, this one should have had a 1/2 in front of it already. So this should have 1/2 there. Yeah, so this one should be over 2. Okay, let's look at number 7. A integral of sine squared x dx. Okay, sometimes we can use trig identities to transform integrals we do not know how to evaluate into ones we know how to evaluate. So in your sheet, what does sine squared x, what's another formula for sine squared x? Where we don't have an exponent. I know, yeah, we can use cosine squared plus sine squared equals 1. We can have 1 minus cosine squared. No, we don't want squared terms because we can't integrate those. One over sine x? No.
wait, you said don't use cosine squared, since we're.
1, right. In your sheets, you'll see this. In the trig functions, so trig identities for sine squared. What you're looking for is one that isn't squared, no exponents. We've been doing them all the time where it has cosine u type equation. So we can change this one to 1 minus cosine 2x over 2 dx.
Does it really work for integral?
For which one?
For integral, does changing these work for integral?
No. Look at the sheets I gave you, the identity sheets. This is trigonometry. This isn't calculus. This part is not calculus. This is trigonometry.
That's for one equation. No, sine 2x, where I had to change 2x, sine 2x to 2 to sine x sine x. Sine X.
You could also done a sine 2x because sine 2x would be sine u. Use substitution. No, I said that's the reason we want cosine 2x. It'll be the same, it's the same procedures as if you just had sine 2x. We can integrate this one using substitution. So du, we're missing a 2, so it'd be 1/2 sine u du.
That's it.
The trig identity. Or double angle. So now we just look at this equation here. This is a constant, it can come out in front. So we're just taking 1 minus cosine 2x dx. So it's integral of 1 dx minus the integral of cosine 2x dx. The integral of 1 is what? Just x, yeah. Minus the integral of cosine 2x dx. So this is cosine u, we need du. U is 2x, so du is 2. So we need a 1/2 in front of here. The integral of cosine is sine. Plus c. That's x over 2 minus sine 2x over 2 plus c. Don't know, sine x over 4, because I distribute that becomes 4. And there's your answer. B, integral of cosine squared x dx. So what does cosine squared x give us? Look at your trig charts.
1 plus cosine.
So now we're going to integrate with respect to 1 plus cosine 2x over 2. Bring the denominator out. 1 plus cosine 2x. Integral 1 dx plus the integral of cosine 2x dx. Integral of 1 with respect to x is x. Cosine u du is equal to 2. So I need a 1/2 in front of there. Integral of cosine is sine 2x plus c. Distribute. I get x over 2, 1 over 4, sine 2x plus c.
the middle part where, where's that one half come from, the cosine?
Because when we integrate this one using the backwards chain rule, it's cosine u du. What's du is 2. We're missing a 2 here, so we have to put a 1/2 in front. Now it's integrable. So it's integral u. Example C. Tangent x du. That should be x dx. Actually, let's look at it both ways. Integral of tangent x du as opposed to that one. What's the integral of tangent? Look at your charts. I gave you the things for a reason. I'm just going to stay here till y'all get me the answer. Yeah, so the integral of tangent is that. So let's look at this. Tangent is sine over cosine. The derivative is negative sine. So looking at this one, we get the integral of negative. So we're missing a negative here, so it's negative there. So it's negative du over u. So what is du over u? Ln u. So it's ln of cosine x remember, what does a negative in front mean in front of a logarithmic equation? That's the coefficient. So it's the same thing as ln cosine x to the power -1, which is 1 over ln absolute cosine of x. 1 over cosine is what? So it's ln 1 over cosine, which makes it ln of secant. Again, the better you understand or memorize your trig identities, everything you learn in algebra, the better it's going to be for you. And if you're deficient in any one of them, you really don't have any free time. You really don't have time to waste texting on your phone, watching videos, playing games. You have no time of that. You have time to study and learn this stuff, the stuff you should have done 3 classes ago. All right, so let's look at example 8. Are you finished writing all down? Okay. I'm sorry, I should have asked you before I did that. I looked at the clock and we're going to finish the class tomorrow, though. An integrand may require some algebraic manipulation before substitution can be applied. Here are some examples. The integral of dx, e to the x plus e to the negative x. And then b, integral of secant x dx. Well, we have to do it so we don't have any negative exponents first. So with on the bottom, what it looks like right now is that. So what do we do on the bottom to fix it up? Rationalize it. So I multiply everybody down here by e to the x and e to the x on top. I'm multiplying by 1. So I have e to the x dx. E to the x is e2x. E to the x divided by x is 1. So I can move the dx back here. Algebraically, what this gives us is e to the x squared plus 1 squared. Because if you look at your integral functions, you're going to see that there won't, up until now, there's not much you have down there that work. You won't be able to find it anywhere. But if you rewrite it this way, now look at your chart. Try to find this equation. Well, what's u going to be in this case? What's u going to be? One? U's going to be 1? No. It has to be an x value of x. So it has to be e to the x. So u is e to the x. What's du? Also e to the x. So what we have here is du u squared plus 1 squared. Again, it's the algebra stuff you have to do to set it up so you can use the charts.
Why is you not 1 since we're using the 10?
U can never be 1. Because what's the derivative of u? What's du going to be? 0. If it's 0, the whole thing's 0. So that's why it'll never be a constant. It's always a function of x. Remember, what we have here is u has to be a function of x. It'll never be a constant. So don't ever say it's constant. So what does that look like? What does 18 tell us going to be? What's the integral going to be?
1 over 8 tangent, running lots of.
The inverse tangent of u plus c. The inverse tangent. What is u? E to the x plus c. And there's our answer. Because it's u squared plus a squared on the bottom, du on top. So what you'll look at is du u squared plus a squared. tangent of u.
What happens to one over A and U over A? What does that mean?
A is this number. Is the constant. Well, if it was 4, then it would be 2, then it would be 2, because it's 2 squared. Even though it's supposed to have 1 over A, since A is 1, there's nothing there. Okay, B. Let's look at the next one. This one's typical. Remember what we did in the first chapter when we had functions that were 0 over 0 and we had radicals in there. We used the conjugate of those functions. Here we're going to do something similar to it. We have this is my u. So du is 1. So what I have here is secant x. 1 is made up of secant x plus tangent x over secant x plus tangent x. The reason for that is now when we distribute that secant squared, what do we get? We'll get secant squared x plus secant x tangent x over secant x plus tangent. What's important about that one? Our u is the denominator. What's du? What's the derivative of secant? What's that?
Root of theta.
The derivative of secant is
And
secant x tangent x. What's the derivative of tangent? Which is what we have up here, secant squared x. So now what we have here is du over u. What's the integral of du over u? Ln absolute value of u plus c. So our final answer would be ln secant x plus tangent x plus c. The reason we use secant plus tangent is simply because it would have put us into that form. We wouldn't use cosecant and cotangent because that would give us nothing. Now, on your note sheet, on your example sheet, you see right below that example, you see the 4 rules of integrals of the tangent, cotangent, secant, cosecant. the integral of tangent of x is equal to the ln of secant of x. The integral of secant x dx is the ln of secant x plus tangent x plus c. We have the integral of the cotangent x dx is equal to the ln of sine x plus c, and the integral of cosecant is equal to the negative of the ln of tangent of secant plus cotangent. Or cosecant, I'm sorry. This is the cosecant, it's just the opposite. These are on your sheets, but here we have faster reference. Bottom line, if you get stuck and something doesn't work, try something else. There's no quick, easy magic bullet to see these. If it doesn't work, try something else. Yep. And then eventually you start seeing these things. And again, then you start, by the more you use it, the more you look at those charts, the more you memorize.
Yeah, for me, like, during the last couple of semesters, when it's trigonometry, it's just
Applying it, doing it over and over, yeah.
you know, it's stuff on problem for $2.
Oh, yeah, that's why I can't stand using calculators. Evaluate this one. So as you get started, what year are you going to be? And therefore your du is going to be, yeah, so we can look at this as du over the cube root of u. Which is du u to the power 1/3, u to the power negative 1/3 du. So what's the integral of that one going to be? It's just u to the power n. It's going to be u negative 1/3 plus 1 over negative 1/3 plus 1 plus c. So 1/3 plus 3/3 makes it 2/3 over 2/3 makes it 3/2 u 2/3 plus c. U is x squared plus 1, 2/3 plus c. And there you have it. I could tell that you were trying to make it more difficult than it was by looking at the chart of the formulas. No, it's just this one here is just straightforward. It looks ugly. It looks ugly. But once you define what u was, you have du. So it's du over u a square root of u.
So it's already set.
It's set up for you already, yeah. All you have to do now is get the u from the top to bottom to the top, make it a negative exponent, and add 1 to it.
So really what these is just getting. Right, like it's reverse chain rule. But, okay,
And plug in the, yeah, the substitution, the u du part. Okay, that does it for that one.